All right, so we are on homework 16, which is the beginning of chapter 8, which is going to all be about hypothesis testing and probably really why you do statistics, at least if you're in behavioral sciences. First thing they're going to talk about is determining the null and the alternative hypothesis. There's always two cases that you could have to any problem. One might be equal and the other might be not equal. One might be greater than, the other one would be less than or equal to. The null always has the equal in it. So it says the breaking strengths of cables produced by a certain company are approximately normally distributed. The company announced that the mean breaking strength is 2,180 pounds with a standard deviation of 180.5. A consumer protection agency claims the actual standard deviation is higher. That's what we're looking at. The actual standard deviation is higher than the given standard deviation there. So, standard deviation, our little symbol looks something like that. If I want to say the actual standard deviation is higher, I would say it has to be greater than, right? So, answer. If my actual standard deviation is higher, notice it doesn't have the equal sign with it. If it doesn't have the equal, it's going to go for your alternative hypothesis, which is your H1. So my standard deviation is higher than my 180.5. My null hypothesis then is the opposite of what I have there. My standard deviation would be less than or equal to the 180.5. The null always has the equal sign in it. So whether that's part of the word problem or if it's the inverse, the one with the equal always goes in for the null. Question number 2 then. The mean height of a certain kind of plant is 156 centimeters. Suppose we want to carry out the hypothesis test to see if the mean height of when these plants are treated with a certain chemical differs from 156. So on this one we have to use the symbol for mean. If it differs from 156, it would be not equal, right? Does not equal 156. Again, since this doesn't have the equal sign, that's going to be your alternate hypotheses. That means your null hypotheses would be the opposite, which means it does equal 156. So I'm either testing does it equal 156 or does it not equal 156. The third one there, it says a presidential candidate claims that the proportion of college students who are registered to vote in the upcoming election is at least 62%. Suppose we want to sample a number of college students and carry out a hypothesis test to see if this claim may be refuted. So we have to figure out at least, and we're doing a proportion here, and so again we have to use our symbol for proportion, which is just a P. What math symbol would be at least? If it's at least 62%, I would be doing greater than or equal to, right? If it's at least 62%, we're doing greater than or equal to. They also, with the 62%, will use the decimal, 0.62 instead of the percent. That one does have the equal, so that one is your null hypothesis. So that's going to be your first answer. P is greater than or equal to 0.62. That means your other answer, your alternate answer, if it's not greater than or equal to, it would be the less than, right? We'll be doing this on every problem for the next probably 4 homework pages. So we'll get used to doing this. type 1 and type 2 errors. They have two different kind of errors. I'm going to, where do I want to write? Where can we see? I'm going to do that. So, when I'm doing my testing, I have my null hypothesis and I have my alternate hypothesis. If, I'm going to do that this way. If my null is true or if my null is false. If I reject the null, if I reject the null and the null is false, that would be the correct thing to do. If I reject my null and my null is false, that's correct. If I reject the null, but it was actually true, they're going to call that a type 1 error. If this decided not to write, why oh why? We'll do it this way. If I don't reject the null, in other words, I accept the H1 instead of the H0. If I don't reject the null, and the null was true, that's the correct statement. I would accept the HO if it were true. And if it were false, then that's when I get what they call a type 2 error. So, that table's in your reading and in your notes and whatever. They're going to give us this word problem. First thing they're going to have us do is figure out what our null hypothesis and our alternate hypothesis is. Then the type 1 and the type 2 errors. So, some college graduates employed full-time work more than 40 hours a week. Some work fewer than 40 hours a week. We suspect that the mean number of hours worked per week by college graduates is different. If it's different, then I'm going to say that it is not equal to 40, right? If it's different than 40, it's not equal to 40. So, this is going to be my alternate hypothesis. They're going to have you select U does not equal, and then the little drop down you'll use the 40 hours. It's different than 40. That means my null is going to be that my mean does equal, and again I'll pick the 40 out of my drop down. So picking out my null and my alternate hypothesis. So it says, in this context, what is a type 2 error? So if it's a type 2 error, you don't reject the null. 1, my null is false. So here again, you're going to have a drop down. It's going to say failing to reject. I can't write that small. Failing to reject the hypothesis that, and then I'm going to put the null in there, so I'm going to use my mean is equal to 40, when in fact, the mean does not equal 40. So if it's a type 2 error, we don't reject the null. So we're going to say we failed to reject it. The null was when it was equal to 40. When in fact, it really did not equal 40. Now, if we were going to, suppose we decided to reject the null hypothesis. If we rejected the null hypothesis, then we would be making a type 1 error. So if we reject the null, then it's a type 1. If we don't reject the null, it's a type 2. And that's basically what we're picking out from our table. Whoops. Now that my... All right, number 5 again, we're doing our type 1 and type 2 errors. So on the previous page, we had our table. If our null hypothesis was true, we should be accepting that this is correct. However, if it is true and then we reject it, that means we made a type 1 error. If my null is not true, we should be rejecting it. So the correct statement would be right here. If it is not true and we accept it, that's my type 2 error. So it says a coin-operated coffee machine made by big corporation was designed to discharge a mean of 7.1 ounces of coffee per cup. If it dispenses more than that on average, the corporation may lose money, and if it dispenses less, the customers may complain. Believing that the mean amount of coffee dispensed by the machine is different than 7.1 ounces, Big plans to do a statistical test of the claim that the machine is working as designed. Technicians gather a random sample of fill amounts and find that the mean sample is 6.6 ounces and the standard deviation is 0.5 ounces. Based on this information, first of all, we're going to do our null and our alternative hypothesis. If it is different, we're saying the mean is not equal to 7.1. We know that the alternative hypothesis has to be the not equal. So here the mean is not equal to 7.1. And so our null hypothesis always has the equal in it. The null means then it's exactly equal to 7.1. So if it asks for different, my null should be equal, my alternative not equal. In this context of this test, what is a type 1 error? A type 1 error is rejecting the hypothesis that u is, and my hypothesis is u that is equal to 7.1, when in fact it is equal to 7.1. So a type 1 error is when you reject it when it was true instead of accepting it when it was true. So rejecting that it's equal to 7.1, which is what our statement is, the null is equal to 7.1, when that is really a true statement, it is equal to 7.1. And if they were both equal, I should have accepted it instead of rejected it. Third part, suppose that Big decides not to reject the whole null hypothesis. What type of error might he be making? So if he decided not to reject it, then that is my type 2 error. Type 1 is rejecting it when it's true. Type 2 is not rejecting it. So number 6. A consumer advocacy group is doing a large study on a car rental practices. Among other things, the consumer group would like to do a statistical test regarding the mean monthly mileages of cars rented in the U.S. this year. The consumer group has reason to believe that the mean monthly mileages of cars rented in the U.S. this year is less than last year's mean, which is 2,750 miles. So my mean is less than 2,750. Again, that one does not have the equal to symbol with it, so that's my alternate hypothesis. You have it as the null if the equal would be with that. So my mean is less than 2,750 is your alternate hypothesis. Your null hypothesis then is your mean would be greater than or equal to the 2,750. It's got the equal to in it, that's the null. So this time we're going to do a type 2 error. A type 2 error, we failed to reject. It doesn't want to write. Right? If it's a type 2 error, we failed to reject the null. The null is that the mean is greater than or equal to the 2750, when in fact the mean is really less than my 2750. Type 2 error, failed to reject. Type 1 error, the group decides to reject the null. If I decided to reject the null, I'm making a type 1 error. All right, because this is annoying me, I'm going to restart the computer. And so work on your pie chart for a little bit. All right, so what we're really going to be doing is doing what they call hypothesis testing to answer the question if this is true or false. It says a manufacturer claims that the mean lifetime of its light bulbs is 46 months. The standard deviation of this lifetime is 7 months. 50 bulbs are randomly selected, and their mean lifetime is found to be 49 months. Can we conclude that at a 0.05 level of significance, that the mean lifetime of the light bulbs made by this manufacturer differs from 46 months? It says perform a two-tailed test. You do a two-tailed test when it differs, because you weren't here last time, but we had that little curve, and if it differs, I could be at this end or this end. So we're saying that the mean does not equal 46 months because it differs, right? So again, they're going to have you do the null and the alternate hypothesis. This is a does not equal, so that's your alternate hypothesis. The mean does not equal 46. My null always has the equal in it. So here my mean does equal 46. And I'm trying to answer the question, does it or does it not? So, ask you what type of test statistics you have. If I know the population standard deviation, then we do the z-test. We had a z-test, we had a t-test, and we had the chi-squared test. So on these ones, we're doing the z-test because we know the population standard deviation. We are then going to find the value of our test statistic, which is our critical value, which we did on homework 7, and we used the formula that looked like this. Z equaled the sample mean minus the population mean over the standard deviation divided by n. So, our sample mean is the 49 months that it was found to be when I did my 50 randomly selected. 49. I'm going to do this population mean, which is the given mean. We know that it was 46 months, or that's what the claim was, that it was 46 months. Standard deviation is 7 months, n we sampled 50. And how come I wrote an n? 50. And so we're going to find the value of that statistic round to at least 3 decimal places. That you could either put in the Aleks Calculator, or if you just want to use your regular calculator, either way. What do you get when you put that in the calculator? what it was supposed to be. Let's try it again. Okay. 49. Oh, that's my fault. I messed up. I forgot something on here. That's supposed to have a square root over the top. How about I put a square root over the top? That'll make a big difference there. I have it written down. I just didn't write it on when I copied it off my paper. So there's my real formula. Now let's put it in with the square root over the top. This is homework 16. 3.030, right? Because it says to 3 decimal places. That means on my little curve that this is at 3.030, this is at negative 3.030. Now the next part wants us to find the p-value. When I'm finding the p-value, I'm finding the values in each of these 2 places here. So this is where we have to use the Aleks Calculator. The Aleks Calculator does the less than or equal to. So we're going to do P of Z is less than or equal to the negative 3.030 plus the P of Z is less than or equal to the 3.030. Since we have the 2 different ends and I can only do less than to find the middle is what we're actually finding. We're going to find the value of the first part, then we're going to subtract the value of everything less than the 3.030 to get the middle part. And this one says to round to 3 decimal places also. What did you come up with?
0.
Oh, you did them separately?
Yeah.
Okay. You got what?
0.001.
001, and on the second one?
0.998.
0.998.
Oh, I suppose it'd be 9 because it was 7.
Oh. Ignore me because I messed up again. I'm doing all of that. I got to do 1 minus that. P of Z. I should get the same number. That's what I should get. This was this. P of Z, 1 minus that. If this is 0.001, then this side should also be 0.001. That's what I'm trying to say. If I type that in right, because this was all of this less than, I'd have to do 1 minus this amount. You got that 0.998 or something like that. But if this side comes out to 0.001, this side should also be the exact same thing. So my p-value, if I add those 2 things together, which is the next thing down that we can't see, is 0.002. You'll mark it down on yours. If p is less than the significant value, which in this case is 0.05, we're going to reject the null if P is greater than the 0.05, then we are going to accept the null. In this case, this is going to be way less, right? So I'm going to reject my null, which means if I don't accept this, I'm going to accept the other one. The mean is not equal to 46 then, right? So it says, can we conclude that the mean lifetime of light bulbs are made differs from 46? Yes, we can, because we have to accept the alternate hypothesis. We're rejecting the null. So yes, it does differ. Now for fun, if you do your technology activity, I'm going to have you grab that one. You can do your hypothesis test on here. What I'm going to do is I am going to hit the stat button, and then I'm going to cursor over to the tests. And you'll notice that number 1 is the z-test, which is what we're doing. So hit stat, then cursor over to tests. And on the z-test you have an input. You can either input the data by putting in all your values into list 1 like we've done before, or you can do the stats. We're going to go to the stats because we know our stats. Hit enter on the stats. So the mean value here was 46. We're going to put 46 for the first one. Our standard deviation was 7. The sample mean was the 49. The number 50 is how many light bulbs we tested. Whoops, I got to do 50. 50. We did differ, so we did does not equal. So you'll notice you have choices of does not equal, is less than or greater than. We want to do the does not equal, so highlight that and enter. So if we go ahead and go cursor over to the draw one, if my graph shows up, it should look something sort of like what I have drawn. I don't see much shading because they didn't do much shading. But notice underneath there, it says z equals 3.035 and p is 0.0024. There might be some slight rounding errors because of where they carried their numbers off to, but you can double check those numbers to make sure you did your calculations right. Okay? Oh. Why is it snapping me again? The computer just doesn't want to cooperate with me today. All right, number 8 then. See how much of it I can get on here. See if I shrink my screen a bit. There. Maybe we can see it all then. Okay, number 8 then. Number 8 says the breaking strengths of cables produced by a certain manufacturer have a mean of 1,950 pounds and a standard deviation of 55 pounds. It is claimed that an improvement in the manufacturing process has increased the mean breaking strength. To evaluate this claim, 20 newly manufactured cables are randomly chosen and tested, and their mean breaking strength is found to be 1,967 pounds. Assume the population is normally distributed. Can we support that at a 0.01 level of significance, the claim that the mean breaking strength has increased? So if it is increased, we're going to say that the mean is greater, right? The mean is greater than the given mean of 1,950 pounds. So again, the null always has to have an equal sign in it. That doesn't have the equal sign, so that's my alternate hypothesis. The mean is greater than 1,950. My null then is that the mean would be less than or equal to the 1,950. Now notice this time it says perform a one-tailed test instead of a two-tailed test. If it's a one-tailed test, you're either going greater or less. In this case, we're figuring out greater than, so we're finding that little section over there to the right. Again, it's always going to ask you the type of test statistic you're finding. Since we know the standard deviation, we know we're doing the z-test. Our standard deviation is known. So again, we're going to find the value of the test statistic. This time I'll write the formula down right. I'm going to take my sample mean minus the given mean over the standard deviation divided by the square root of n. So my sample mean is which one of those numbers? They give you two different means. One's the given mean and one is your sample mean. The 1967, right? That's the one when they did their test. That's what they got for their answer. 1967. We're going to subtract the given mean, or what they think the mean is supposed to be, of 1,950. Divided by the standard deviation, which is 55, over the square root of how many were in our survey? Looks like 20. 20 cables were tested. So if I calculate that out, either that one you can either do on your regular calculator or on the Aleks Calculator. Yep, 1.382 is going to be the value of our test statistic. Now this time notice they're not having you find the p-value, you're finding the critical value. So this is when you did the z sub on your calculator. We're going to do z sub 0.01 to find where that critical value is. So on the Aleks Calculator, if you do z of 0.01, what do you come up with? So you can practice punching these in. What do you get when you do z sub 0.01? 2.326. Okay. So what this is saying, if I'm interpreting that, this is where my null is, because that was the less than or equal to section. This is where my alternate is, because that's the greater than section. My critical value is the value 2.326. This is my test value. Does the test value fall in the null section or the alternate section? Well, since it's less than this value, it's going to fall in this section. 1.382 is going to be over here on that side, right? Because it's smaller than my 2.326. So, since this is where my test is, I have to accept whatever my null statement was. So I have to accept that the mean is less than or equal to 1950. The question says, can we support the claim that the mean has increased? no, we can't accept that. We have to accept that it's less than or equal to, so it didn't increase. So I have to say no, I can't accept that statement. So when they give you the critical value, you mark where your test value is, depending on if it's a less than or a greater than, and that tells you which one of these two things you should accept. I have to accept the null. Mhm.
How do you type it in?
So here you would do the z sub, and then you're using 0.01. And equal. Yeah, okay, that's a 2.326. Yep. So, yep. So when they ask you for the critical value, that's the easier one to do because you just have to do that. Now again, if we take the graphing calculator just to check our answers, we're going to do stat, we're going to cursor over to tests, and we're going to do the stats because we know the statistics on this one. It's already probably highlighted because we did stats on the previous one. Our given mean was the 1950, right? 1950. Our standard deviation was the 55. Our sample mean was the 1967. And our n was 20. This time we did the mean is greater than 1950. So we would cursor over to the greater than. And again, if I go down to the draw and hit equals, it's going to draw. There we can see some shading because our section wasn't so small. But it tells us the test value was 1.3823. Our p-value, which it didn't ask on this one.
Oh, did I do one wrong?
Oh, yeah, it looks that way. Let's look at that again. So hit stat for me and go to test. Number 1 is your z-test. Yep, there, 1950. Oh, the standard deviation was 55. Oh, this is supposed to be 20 instead of 50. This problem, we only had 20 in our sample.
So everything.
And then we want to do the greater than. And then go to draw. Here. So it is showing us that here was the greater than 2.326 was this section here. Since our test value was 1.382, we had to be the other section, which is the null hypothesis. So you can do at least a little bit of double checking with your numbers. All right. Thing is gonna drive me crazy. Let's do the next one there, number 9. So number 9 says a leasing firm claims that a mean number of miles driven annually in its leased cars is less than 13,360 miles. A random sample of 70 cars leased from this firm has a mean of 13,254 annual miles driven. It is known the population standard deviation of the number of miles driven in cars from this firm is 1,080 miles. Is there support for the firm's claim at a 0.1 significance level? So their claim is that the mean is less than 13,360. Right? That's their claim. So, since that doesn't have an equal to, that's the alternate. The null always has the equal to. So the mean is less than 1,360. That means my null would be that the mean is greater than or equal to the 1,360. The null always has the equal to symbol in it. Type of test statistics, since we know the standard deviation, we know we're doing the z-test. We knew that because all of these are the z-tests. So, first of all, we're going to find the value of our test statistics. So, my sample mean minus my given mean over my standard deviation and the square root of n. So my sample mean is what number?
I don't have this homework. It's not in my thing.
In chapter 8?
Yep. I don't have any chapter 8.
Huh, strange. You guys had chapter 8?
Remember I was missing like 3 other ones too?
Here, we'll print that. It'll probably take a minute. So, we said here the mean was greater than or equal to or 1,360. The mean is less than 1,360 here. We're doing the z-test. And now we're finding the value of our test statistic by taking the sample mean minus the given mean over the standard deviation and the square root of n. So on this one it says the sample mean is what number? So in my sample, what is the mean? That is the number, that's the n, that's the number that we sampled. Keep reading that sentence.
Is it the 13?
Ah, there it is. The sample has a mean of 13,254, right? We're going to subtract what the given mean, or at least what the claim of the mean is. The mean is 1,360 there. My standard deviation in this problem is 1,080 over the square root of n. N is how many things they sampled, which was 70. That is what I'm going to put into the calculator in order to find the value of my test statistic. That's printing out back there if you want to grab that. You punch that into the calculator. What do you come up with?
Which one is this 5?
This is
Nine?
number 9.
Can you do that calculator?
Oh, certainly, yes. Whichever calculator you want to use for that one. It could be the health calculator. You could just use a regular one if you wanted to. It's probably easier on the Aleks Calculator to get it punched in the right way. To 3 decimal places is how far we want our answer.
Is that a B or 1 3?
It's a 1-3.
1 3 3 6 0?
Oh yeah, 13360. That's our claim. It's less than that number.
Okay.
What are we getting for the value of our test statistic if you get that punched in?
How do I do it on the calculator, on this calculator? Is this what you want us
On
to
the
do?
regular calculator, you would have to put in the top in parentheses, or you'd have to figure that number out right away. 1,300, or 13,254.
Oh,
That's the second. 13,254 minus the 13,360. It equals, to get that top number, enter. Then you're going to divide that by 1,080 divided by the square root of 70. Square root, you have to do second function.
oh,
So back that up and do second, and see how the square root is in blue? So second function, square root of, oops, it's still up in the exponent. Oh, let's see if we can get that out of there. Oh, we're just going to delete. There, now second function, square root of 70 equals. Is that the right number? That is not the right number. What does that not write? Do I have to put parentheses around the bottom? Let's try it this way. Put in your negative 106. Negative 106. Divided by, and then put parentheses, 1,080 divided by, whoops, no, in the same set of parentheses, because that's all together in the bottom,
okay.
square root of 70. And close your parenthesis, whoops. Gotta close our parenthesis on the other side, so cursor over, delete that, delete again. Okay, now cursor so you're outside the square root, and then close the parenthesis. Now let's hit equal and see if that works. That's the number we should be getting. So
Okay.
yeah, we'd have to put parentheses
Okay.
around that bottom part so it knows that all this is together.
Okay.
So we got negative 0.821. So on, the other two disappeared on me. On this one, we're doing a left-tailed test. Since this is a less than, we're checking this section right here, and that's why this ended up being a negative value, negative 0.821. Now, in the next part, you have to use the Aleks calculator. So go ahead and log on, because those two disappeared on me anyway.
Yeah, the thing is this computer won't let me log on. I was trying to log in earlier. It was not letting me do that.
That's your right through 90. Oops, that's okay. Other user. Somebody was just on earlier, so I'm just going to see what kind of message we're getting here.
Cause it rejected me like 4 times.
We must have just typed something wrong, because now it says it's preparing your desktop.
Okay.
writing in weird spots. So you got logged in there, still working on it.
I need a password.
Oh, that's right. Click in there for me. Go ahead and hit start. Oops. Switch back to the other password. Now hit start. Yes, it did. All right. So, on problem number 7, which you missed out on, we had this. If my p-value is less than the test value, we would reject the null and accept H1. If the p-value is greater than, we accept the null and reject H1. We have to first find our p-value. So this is what we were doing last week, was finding the p-value. So on
Reject.
reject the H sub 0, which is the null,
Okay.
and accept the H1. If we reject this one, we're going to accept this one.
Okay.
If it's a greater than, it's going to be the other way around. We're going to accept the null, that would be true, and reject the H sub 1. My pen didn't want to write exactly where I thought it should. So we have to find the p-value. So to find the p-value, we're going to do p of z is less than whatever the number is we got here, which we got negative 0.821. So in the Aleks calculator, you're going to just punch that in. Since it's a left-tailed test and our z goes less, we're just going to put in that. And we're going to find that to 3 decimal places, it says.
Okay, which one do I use?
The P of Z one.
This one?
P of Z, this first one. Yep, P of Z, and then you're going to put in that answer we got on the previous part. Negative 0.821.
Just equals?
Yep,
Is it 0.20? How many places? 3?
3.
6.
Okay, so what we're going to compare that to is the significant level that it says up here. So if I have 0.206 and I'm comparing it to 0.1, is this greater than or less than that?
Greater.
It's greater. Since that's a greater, we are going to do this one down here.
Okay.
We're going to accept the null. That means that the mean is greater than or equal to this number.
Okay.
The question says, can we support the claim that the miles driven annually is less? No, we're saying that it's greater than, right?
Mm-hmm.
So, can we accept that claim? No. We can't say it's less because we ended up it was greater than. Then we said just to double check our calculations, we can use our calculator, right? And practice using that. So we hit the stat button. We cursored over to tests. And we're doing number 1 for the z-test because that's the type of test we're doing, right? And we're using the stats. So stats should be highlighted. If it's not, cursor over to stats and hit enter. If you've already been using stats, it's already highlighted. Then we have to put our numbers in the correct places. So, the X bar one was the 13,254. The mean one is the 13,360, right? So the top one is the 13,360. Our standard deviation is this number here, which is the 1,080. Our X bar number is the 13,254. And our N is the 70. You don't do the square root, you just put the 70. That's how many things we tested. On this one, when we're doing our test, we're doing the less than, right? So we highlight the less than, then we're going to cursor down to where it says draw. And we're going to draw, and it's going to draw something that sort of looks like what we drew up here, but more importantly underneath, notice it gives you the z-test value, which is the negative 0.8212 because they carried it out a little farther than us, and the p-value 0.2058. Whoops. Okay. So, 13,250. Whoops, no, the top number, the mean number, up on the top, cursor that up. Why doesn't that want to move? It's stuck, huh? Let's just hit clear. No, won't move? We'll put a number in there. It just doesn't like to be blank. So, the mean number should be the 13,360. The X bar number is the 13,254, right? The standard deviation is the 1,080. And then the N number is the 70. On this one, we are doing less than. So I'm going to enter on that. Yours is going to draw orange. We're going to go over to draw. And there it is drawing it. Since we were checking a less than, it highlighted the left side. There's the z-test value. There's the p-test value. So that number should match here. This number should match here. Other than they rounded it off to different spots.
Okay.
We still need to know how to interpret the test, but at least we can double check our calculation. I don't know where those two got lost at. All right. Now, we are going to basically do the same thing that we just got done doing. Only now they're going to ask us about the type of error that we might have, which we talked about earlier, type 1 and type 2 errors. So I'm just going to remind you since you missed that. So, if I draw my table, if our null value is true or our null value is false. If we reject, almost can read that because it wants to write a little bit farther over than I have it. Now, if we reject the null and the null was really true, then we have what they call a type 1 error. This would actually be the true statement. If we reject it and it was false, that's the true thing to do. If we don't reject, I don't know why they just don't say accept, but they say don't reject the null. If we don't reject the null and it was true, that would be the correct thing to do. Otherwise, we have what's called a type 2 error. So if we reject the null, type 1 error. If we don't reject the null, type 2 error. Problems 4, 5, and 6 talk about that. But we'll talk about them some more. So, problem number 10 says, a union of restaurant and food service workers would like to estimate this year's mean hourly wage for food service workers in the U.S. Last year's mean hourly wage was $8.16. There is reason to believe that this year's value is greater than last year's. The union decides to do a statistical test to see if it can conclude that the mean has increased. The union chooses a random sample of 75 wages this year. Suppose the population of hourly wages of food service workers in the U.S. has a standard deviation of $1.15, and that the union performs its hypothesis test using that 0.01 level of significance. Based on this information, answer the questions below, carry your intermediate computations to 4 decimal places, and round your responses as indicated. So, on all of these ones that we were doing on the previous ones, we had our null and our alternate hypothesis. Here they're going to make you put it together instead of having them separate like on the previous questions we just did. So in this case, we want to see what the question says. It says that it's reason to believe that this year's value is greater than last year's value. So we are checking to see if the mean is, in one of these I'm going to have the greater. You always use the one that does not have the equal sign in the alternate one. The one with the equal sign will always go with the sub-zero one, the null hypothesis. So since I'm doing a greater, the greater's going to go there. Which means this one here, if it's not greater, would be less than or equal to. And we are comparing it to last year's. So last year's number, $8.16. That's going to go in for both of them. So, assuming that the actual value of the mean is $8.57, what is the probability that the union rejects the null hypothesis? Round your response to at least 2 decimal places. Now we're actually going to combine what we did last week with what we did this week into one really big long thing to come up with this one number that's going to go here. So, last week we had a formula that looked something sort of like this. I'm going to take my mean value, and here we had plus or minus, but sometimes we use the plus and sometimes we use the minus, depending on if it's a left-tailed or a right-tailed. Z sub something, and then we had our standard deviation times the square root of n. Sort of remember seeing that formula last week? So, in this case, we are going to use the greater than, right? The greater than means we're going to use the plus sign and not the minus sign on this problem. So I'm going to put that little note there so you know why I use the plus. So, my mean value here is the $8.16 that we had. Plus, we're going to do Z sub, and that's going to be this level of significance. Right there, 0.01 times the standard deviation. The standard deviation is right here, $1.15 over the square root of n. N is how many people they sampled. They sampled 75 people. We punch that into our Aleks calculator.
$1.15.
1.15, yep, that was our standard deviation over the square root of 75. All right, so you're going to do 816. Whoops, 8.16, $8.16. Plus, since we're doing a greater, Z sub, so we're using, yep, and then we're going to use 0.01, and then, whoops, then cursor or click up behind there so we can put the parentheses behind that. There we go. Parenthesis, 1.15 divided by the square root of 75. Square root, yep, 75. Click behind there and close the parenthesis. Equals All right, so we are not done. That's only part of our problem, but I'm going to write that number down. 8.4689, because it says to do at least 4 decimal places. So now this is what we did last week. We're going to combine it with what we did this week. So this week then, we did a formula that sort of looked like this, but they changed it a little bit on us because we have different values. But this is the one we just got done using previously. This value here is going to be your C value when you plug that in. And this value here is going to be that U sub 1 value. So you have to go to your word, or to the question. Okay? So we're going to do 8.4689 minus 8.57 over standard deviation was 1.15 over the square root of n, and n was 75.
So this number we take away 8.57. Okay.
Yep. And then we hit equal, and then when we divided, we put that in parentheses. Oh, and Aleks Calculator, yeah, it'll go in there nicer than when we use the other calculator.
Okay.
Okay, so hit equals. And then we're going to divide that by 1.15 divided by square root of 75. And hit equals. All right. That number is negative 0.7613, right? We're still not done because now we're to the last step of the problems that we just did. We still have to find the p-value. So, since we're finding this side of a right-tailed test, we're going to do 1 minus the p-value because the p is less than on our calculator of z is less than or equal to that answer, negative 0.7613. If it's a less than, you don't need the 1 minus, but since it's a greater than, we have to do the 1 minus. That's what we did last week. So now you're going to punch that into the Aleks Calculator.
Okay, so then, do I clear this last number?
Yep, you can clear that last number and do 1 minus. The P of Z is less, well, it's probably just less than. I don't think it has the equal to on it. Oh, it does have the equal to. Less than or equal to or negative 0.7613.
Negative
0.7613 equals. And after all of that work, it says round that response to 2 decimal places. 2 decimal places, you get 0.78. So really all of this, just to answer this one question, is doing what we did last week combined with what we did this week and then finding the p-value this week. So it combined all of that stuff into one big super long problem.
Is there a way that we can get the steps? You know what I mean? Like I have all this on here, but like if I go back and look at it later, I'm gonna be confused here on how to get that second part. I mean, we don't have to do it now, but
Right. We'll do a few more anyway. But here we did that first, and then we did this second, and then we did this third. All of that went to find that one number there. But really it's just combining all of what we did up to this point into one big long thing. So, What is the probability that the union rejects the null when in fact it is true? If it asks for what is the probability that it's going to reject the null when it's true, I'm looking at the significance level. So this number and this number should match. Okay? And then now here's where we're talking about the type 1 and type 2 errors. Now here we're talking about a type 2 error. So if we have a type 2 error, we don't reject the null when the null is false. It says, suppose the union decides to perform another statistical test using the same population, the same null and alternate hypotheses, and the same sample size. But for the second test, the union uses a significand of 0.05 instead of 0.01. Assuming that the value of $8.57 stays the same, how does the probability that the union commits a type 2 error in the second test compared to the probability that the union commits a type 2 error in the original test? Well, look at this. If my significance is 0.5 instead of 0.1, you're less likely to commit an error, right? Because I have a bigger room, more room to make more room to make my error. I don't know how I want to say that, but 0.5 would give you more chances to get it right. So in this case, the probability of committing a type 2 error in the second test is going to be less on this one. Because if I had 0.5 compared to 0.1, I have a less chance of making that error. Right? If I only have a 0.01 chance of making the error, then that's more likely I'm going to make an error. If I have a 0.05, I get a bigger room for error, and so it's less likely I'm going to make my error. So, this question here takes all that stuff that we did in Chapter 7 and in Chapter 8, puts it in one great big huge long problem. We'll go ahead and do another one. Then maybe you can get your steps there. So, number 11. A coin-operated coffee machine made by a big corporation was designed to discharge a mean of 6.9 ounces of coffee per cup. If it dispenses more than that on average, the corporation may lose money. If it dispenses less, the customers may complain. Believing that the mean amount of coffee dispensed by the machine is less than 6.9 ounces, Big plans to do a statistical test of the claim that the machine is working as designed. Big gathers a random sample of 150 amounts of coffee dispensed by the machine. Suppose that the population of amounts of coffee dispensed by the machine has a standard deviation of 0.6 ounces, and Big performs its hypothesis test using a 0.01 level of significance. So first thing we have to do is figure out what the null and the alternate hypothesis is. What they believe is that it dispenses less. So again, since less doesn't have an equal sign, the less is my alternate one. That means my null would be greater than or equal to, right? If it's not less, it's greater than or equal to. The amount that we're comparing it to, 6.9. So for my null hypothesis, I'm going to do greater than or equal to 6.9. For my alternate one, less than 6.9. Which means we're going this way. We're doing to the left side. So, now here's where we have that big long problem that we have to do all those steps on. My first step is using my formula that we had before from last week. We have the mean plus or minus z sub whatever it is, and then the standard deviation over the square root of n. Since this one is going to the left instead of to the right, we're going to use a minus instead of the plus. On the previous one, we were going to the right, we used the plus. I'm looking at number 12. How about I look at this one? So, my mean that I'm comparing it to is the 6.9 minus Z sub the significance level is that number there. So 0.01. My standard deviation says it's 0.6 over the square root of n. N, we sampled 150. That's the first thing we're going to do. So, put this into your Aleks calculator, find that answer first. I'm just going to write a little note. Plus if it's to the right, minus if it's to the left. And then this we're going to go to 4 decimal places on our intermediate calculations because we got a bunch of steps to do. So once you get that punched into the Aleks calculator.
It's 150.
That's 150, yep. That's the number we sampled. We got 150 samples. Yep, that looks right. 6.7. What's
How many places do you want? 3?
4 decimal places.
6.7860.
Okay, that's our first step. Our second step now is using that formula that looks like the one we did today, but they changed it a little bit because our numbers are different. It looks like this. C minus the mean over the standard deviation and the square root of n. This value here is your C value. This value here is your U sub 1 value. So, we are going to do 6.7860 minus 8, whoops, that's a 6, 6.75 over my standard deviation, 0.6, and the square root of n was 150.
Is that 6.75?
This is the 6, this is this number, 6.7860 minus this number, 6.75, yep.
Put that in the calculator.
And then we put that into the calculator, exactly. Whoops.
Oh.
Something doesn't sound right there.
Then so
Let's
do.
see. Oops. Just, yeah, undo so I can see what you had typed in. Oh, see what you have typed in? that whole thing should be on top of the fraction, and you've got part of it. Remember we had to hit equal before?
Okay.
So undo a bunch for me. Oh, there we go. Put your 7-5 in. Hit equals first, and then do the bottom of your fraction. So divided by the 0.6 divided by square root of 150. There we go. Okay, so that number is, to 4 decimal places,
0.7355.
0.55.
Yeah.
Okay? She didn't round off, she used the full number on the calculator, so you might have a little bit different number here because if you round it, it will be different. Now, third step. We have to find the p-value. So, if it's less, you just do p of z is less. If we were doing greater, we would do 1 minus p of z is less. The last one we did was a greater. This one we're doing a less. So on this one, we just have to do p of z is less than whatever you got for your answer here. So, I'm going to write it up here. P of z is less than 0.7355. So if I'm doing a less, I can just use the number. If I'm doing a greater, I got to do 1 minus that because I'm doing the opposite. And then I'm going to punch that into the Aleks Calculator and round our answer finally to 2 decimal places. So clear that out, do p of z is less than, yep, or equal to that number. To 2 decimal places, what do you get? 0.77, that's exactly what you should get. Okay? All that work is adding all those steps together as stuff we did in the last couple days. Now, the next part is the easy question. When it asks what the probability is, I'm going to look back at my question for what is my test for the significance level. This number right here. Right? That's how it was on the previous one too. What is the probability? That's what I'm testing. Okay, so last part of this. Suppose that Big decides to perform another test using the same population, the same null and alternate hypotheses, the same level of significance, but this time he's going to sample 125 people instead of 150. If I sample less people, am I going to have a more or less chance of making an error? If I sample fewer people, am I going to have more or less chance of making an error?
By 1 time.
I'm going to have a bigger chance, right? The fewer people I sample, the bigger the chance I'm going to get an error. So, the probability of committing an error is going to be greater because I sampled less people. All right. Last one on here. Again, these are really long because they're just doing everything that we did. If you can just do this one question right on the test, they wouldn't have to ask you a whole bunch of other things. Number 12 here. A psychologist is studying a smoker's self-image, which she measures using the self-image score from a personality inventory. She would like to examine the mean score for the population of all smokers. Previously published studies have indicated that the mean for the population of all smokers is 80. The standard deviation is 15, but psychologists believe the value for the mean has increased. So if it increased, what math symbol would we use? Greater than, right? The greater than is going to go in for your alternate one because it doesn't have an equal to on there. Greater than 80 is what we're comparing it to, right? 80 was where it was. That means the null is going to be what math symbol? Less than or equal to, right? If it's not greater, it's less than or equal to. The null always has the equal to in it. And of course, it's still going to be compared to that same number. So on this one, since we're doing a greater than, we're doing a right side test. That makes a difference on what we use on our formulas, right? Oh, they switched these around. They asked the easy question first. What is the probability? What is the probability? What number do we use when it asks what is the probability? There's no math to do. We just pick the number out of the word problem. And I think they use the same number on every one of these problems. You use the level of significance, right? So when it asks what's the probability that I'm going to make an error, I'm looking at that level of significance. That's the chance I'm going to make an error. Now we're doing the long part on the second part. They switched it around. So we are going to do the mean. And should we use a plus or a minus when we do our formula? We're going to do a plus because we're going to the right. If it's a minus, we would be going to the left. So we use the plus. Then we had z sub standard deviation over the square root of n, right? So my mean, this number here, 80 plus z sub, and that sub number is your level of significance, so 0.01. My standard deviation says my standard deviation is 15, and my n, I sampled 50 smokers, so square root of 50. Punch all of that in to find our first number, but we have 3 steps to get to the end. Nine what?
934.
3, 4? Okay. Is there a number after the 4 or is it a 0? 9? Because it says to carry it out to 4 decimal places. So that means 4 after the decimal. So 84.9349. Getting that number? Haven't typed it in yet? Still writing? Okay, so we got the 15 divided by, oops, undo that, undo again. Let's do your parentheses first. Now put your 15 divided by square root of 50. And behind there, close your parentheses. So you might just want to put parentheses on here so that you know that you need to put those in there, right? All right. That's the first step. Our second step, we did C minus the mean from the problem over the standard deviation and the square root of n again. This value here is the one that is going in for the C. This value here goes in for the mean sub 1. So 84.9349 minus 86 over my standard deviation of 15 and the square root of 50.
point, the 1, 2, 1? No?
Should get a negative number. Clear that out or undo that. Oh, yeah, we got a whole more. Okay, so we have the 84.932. Okay, we're going to minus the 86. Hit equals. Then divide that by the 15 divided by the square root of 50. Equals. Okay, maybe the decimal wasn't in there. Clear that out. Let's just start all over. Okay, 84.9349. Maybe you didn't have a point. 9349 minus 86 equals, or enter, yep. There we go. Divide that by 15 divided by the square root of 50. Equals. That looks better. So, we come up with negative 0.502, right? So we are going to do P of Z is less than or equal to negative 0.502. Draw my arrow.
Want to do that too?
Okay. So, clear that out. Do P of Z is less than or equal to negative 0.502 equals. And this we are rounding off to 2 decimal places. To 2 decimal places we get
0.31.
0.31. Now on this one, even though we were testing to the right, because this was negative, it was doing to the left, and the numbers should end up matching like when we did the 2-tailed test. That's why we didn't have to do the 1 minus on that one, because of the negative. Now, the next one is weird. It says, suppose that the psychologist decides to perform another statistical test using the same population, the same null and alternate hypotheses, and the same level of significance. But for the second test, the psychologist chooses a random sample size of 150 instead of a random sample size of 50. Assuming that the actual value of your mean is 86, how does the power of the second test compare to the power of the original test? The power is like the p-value. So when they ask for how the power compares instead of the chances, it ends up kind of being the opposite of what you normally think your answer should be. My percent is going to be lower or higher depending on if I am going to have more or less chance. So when I think about this, if I think about, well, I sampled more people, I would think that, oh, since I sampled more people, I have less chance of making an error. That means your power, your percentage, is going to be a greater value. And so the power for the second one is going to be bigger than the power of the first one. So if you have less chance of making an error, the power or the percentage is higher. It'll be the opposite of kind of what we thought of when we did the other ones. So if I have more chance of making an error, then my power or my percentage is less, and vice versa. Alrighty. That is the end of that one.